Okay, now we're going to look at area and estimating with finite sums. One of the major problems that we look at in calculus is finding the area under a curve. Here we have the curve y equals 1 minus x squared, and we're looking between 0 and 1, and we're looking at the area under the curve between the x-axis and the curve. Now if we want to find this area, we can't use some simple geometric formula. This is not a rectangle or a square or a circle or a trapezoid or any other figure that we have learned formulas for. Now what we're going to look at here is estimating this area using what we call a rectangle method. Now what we're going to look at here, you see two different pictures. On the left we have our graph of y equals 1 minus x squared, and you'll see what we've done is we've made two rectangles. Now notice that if I find the area of these two rectangles, I have found an area that is larger than just the area under the curve. But what we're going to do is we're going to estimate. Now our estimate using just two rectangles is not going to be as good as the estimate when I use, say, four rectangles, as you can see here. Notice the pink area, which is really the overestimate, okay, because we're going to be finding the area of these rectangles, and so this area is all too much. But this area combined is not quite as much as the area overestimate here. And as we have more and more and more rectangles, our overestimate will be less and less. Now, what we're going to do is if we want to divide it into two rectangles, we take our interval here from 0 to 1, we divide it into 2. So that would be 0, 0.5, and 1. Okay, that gives us two rectangles. Now, the point on our graph, 0 minus 1 squared, this is 1 minus 1 squared. 1 squared is 1, gives us 1 minus 0 squared. 0 squared is 0. 1 minus 0 is 1. If I plug in 1/2, 1/2 squared, 1/2 times 1/2 is 1/4, and 1 minus 1/4 is 3/4. So that's where these points come from. These are the points at 0 and at 1/2 on this graph. Okay? Now if I want to find the area of these two rectangles, remember the area of a rectangle is just length times width. So the area of this first rectangle is, well, it is 0.5 by 1. This is 1 high, 0.5 wide, so our length times width is going to be just 1 times 0.5. Plus, if we take the area of this rectangle, its width is also 0.5, from 0.5 to 1 is 0.5. Its height is 3/4, because remember that height is your y value. Okay, so we're going to have 3/4 times 0.5, and if it makes it easier, you can use 0.75 instead of 3/4. So 3/4 times 0.5. Okay, now if you type that into your calculator, you're going to get either 7/8 or 0.875. Now this is an estimate for the area between this graph and the x-axis, this area in purple. Now obviously it is an overestimate because the rectangles are bigger than the actual figure itself. Okay? Now let's say we wanted to divide into 4 rectangles. If I use 4 rectangles and you divide the interval from 0 to 1 in 4 parts, you'd have 0, 0.25 or 1/4, 0.5 or 1/2, 0.75 or 3/4, and 1. Okay? Now each one of these, of course we had the 0.01, we had this point, but each one of these are found just by plugging in here. If I do 1/4 squared, that's 1/16, and 1 minus 1/16 is 5/16, and so forth. If you'll just take 3/4 and plug in, 3/4 squared is 9/16, 1 minus 9/16 is 7/16. Okay? And we need these points so that we'll know the height of our rectangles. Now this area is going to be found by adding the areas of these 4 rectangles together. And we, again, still have a little bit of an overestimate. For this rectangle, its width is 0.25 or 1/4, and its height is 1. Okay, so we'll have 1 times 0.25 plus. When I do this rectangle, it's also 0.25, but its height is 15 over 16. So I have 15 over 16 times 0.25 This is 0.25 wide and 3/4 high. This should be a plus here, sorry, plus. So this is 3/4 times 0.25 plus, and this is 0.25 wide, and it's 7/16 high. So I've got 7/16 times 0.25. Now if you will type this in your calculator, you'll see you have 25 over 32, which is 0.78125. Okay. Now this is a little bit better estimate than this, but obviously it's still an overestimate because all of this pink that you see here is extra area that we've computed that's not actually area under the curve. Okay. Now, we could continue to do this, making smaller and smaller intervals. So like we could do 8 rectangles or 16 rectangles and make smaller and smaller and smaller intervals. Then we would get closer and closer and closer to the actual area. So it's very similar to what we learned with limits. As we make more and more and more rectangles, it's going to get closer and closer. Now notice what we have here is what's called left rectangles. We started at the left endpoint. So we started at 0, 0.25, 0.5, and 0.75. And here we started at 0 and we started at 0.5. That's where we started our rectangles, was from the left. Okay? Now if we started from the right, we would have an underestimate. Okay? So this is almost the same as this example, except now we have 4 rectangles and we're starting from the right. So we're starting at 0.25, at 0.5, at 0.75, and at 1. Now this is going to be an underestimate because what we're actually computing is this purple color, and see all this blue is what we're missing that we should have been computing. Okay? What we should have been computing that we actually were not computing. Now, to find this area for this first rectangle, it is 0.25 by 15/16. So this will be 15/16 times 0.25 plus, this one's also 0.25, its height is 3/4, so that's 3/4 times 0.25 plus, this is also 0.25 with the height of 7/16. Now look at the last one. You see this little pink line here? There's actually no rectangle because the height here, this point on the graph, is 1, 0. So it has 0 as its height. So there's actually no rectangle here. Now if you'll type this into your calculator, you will get 17 over 32, which is 0.53125. Okay? So here we have another estimate. Now, since this is an underestimate, this is an overestimate, we can kind of agree it's got to be somewhere between 0.7128, 0.53125. It's somewhere in that range because we have an overestimate and an underestimate. Now you can see that's a fairly large gap. Okay, so we would need to make more and more and more rectangles in order to actually find a closer and closer approximation to the area. Another thing we can do is instead of doing left endpoints or right endpoints, you see that they each gave us a big overestimate or underestimate, we could do midpoints. Now notice what happens here. If we look at our interval from 0 to 0.25, and we look in the middle, which is 0.125, and we make a rectangle that is that height, notice this part is, there's a little slice here and there's a little slice here. Okay? And then over here, notice there's a little piece here and a little piece here. Now this is too much, where we've done too much, and this is where we haven't done enough. So there's some blue and some from underestimate, and there's some pink from overestimate. Okay? But what we do is we do 1/8, 3/8, 5/8, and 7/8. Those are the midpoints of each one of these intervals, and we compute the y values. Then when we go to find the area for this first rectangle, it's still 0.25 wide. It's just 63 over 64 high. So we have 63 over 64 times 0.25 plus. Our next one is also 0.25 by 55 over 64 plus, this one's also 0.25 by 39 over 64. And then the last one is 0.25 by 15 over 64. Okay, now type that into your calculator, and you're going to get approximately 0.671875. Okay, now notice this is kind of in between those, this underestimate and that overestimate. That overestimate was 0.78125. So this is kind of in between those two. Now this is still not exactly the area under the graph, but what we're doing is we're just getting estimates for that. Okay. Now, look at these examples. These have 16 rectangles. And you'll see, as I get more and more rectangles, there's less underestimate and less overestimate. Okay? This area here is approximately 0.63, and this one's approximately 0.7. This one's a little bit too big, that one's a little bit too, or this one's a little bit too small, this one's a little bit too big. But we can keep doing that. This gives us some of the actual answers. If we did 2 subintervals, if we did 4 subintervals, 16, 50, 100, 1,000, notice as you get more and more intervals, you start to kind of hone in on one particular number. And if you look at this last one where you have 1,000, this is getting very close to 0.6 repeating, which remember is 2/3. Okay, so as you do more and more and more rectangles, you'll get closer and closer and closer to that actual area.